All right, we have multiple methods to be able to solve quadratics now. And so looking just at number A, it looks like we can just square root both sides. It's already in a perfect square factors format equal to a constant. So here I go, able to just solve by square rooting. And so whenever I square root anything squared, whatever's inside that was in squared jail can now come out. And then that's equal to plus or minus root 8, and that radical can be simplified. So we're going to add 6 to both sides, and we get 6 plus or minus root 8, but let's simplify that radical. Root 8 can break down into root 4 times root 2, and root 4 is a perfect square. The square root of 4 is just 2. So this becomes 6 plus or minus 2 root 2. And that means I have 2 real roots, 2 real solutions. So that was just solved by taking the square roots. Now in this next one, it looks like a nice factorable trinomial. Let's test it out and see if it works. Let's try the method of solve by factoring. What goes in the middle when it's a plus x? It's just an invisible 1 there. So 5 times 6 makes 30. Which one gets the negative? So an x minus 5 factor and an x plus 6 factor equal to 0. And then we solve each piece by zero product property. So this again is 2 real roots. And this method that we used was factoring. Okay, this one over here, let's check this out. I'm just going to try adding 9 to get 12 is equal to x squared. And then check it out. I can just solve by square roots. So plus or minus root 12 equal to x. And I can simplify that radical. What times what equals 12? 4 and 3. So this is going to make plus or minus 2 root 3. And this again is 2 real roots. Okay, this one right here, let's try the method of factoring. Notice there's a coefficient in front, so I'm going to go -6 and a 1 in the bottom. Where does the -6 come from? It comes from the 3 times -2, the A times the C. So what times what equals -6? 2 and 3. I would need to give 2 the negative for 3 minus 2 equals +1. But this time my factors are not just x minus 2 and x plus 3, because there's a coefficient of 3 in this one. So we need to put that 3 in there and then reduce it out if necessary. So this front factor is okay, but this back factor turns into positive x plus 1. These are my 2 factors. I want the solutions because I'm solving. So I set the 3x minus 2 equal to 0 by 0 product property, and the x plus 1 equal to 0 by 0 product property. I get one nice integer, but over here I'm going to have a fraction. So I get x equals to 2/3 and x equals to 1. There's my 2 real roots again. All right, this next one can be done by factoring a greatest common factor. What's in common with 2x squared and 6x? A 2x comes out front and x plus 3 is inside. Those are my 2 factors. Since there's an x in front, I set one x equal to 0, and I set the other x equal to 0 by 0 product property, and I get x equals 0 as one solution, and x equals -3 is the other solution. These are my 2 real roots. Again, that method was solved by factoring. And last, this guy can just be square rooted. Square root of 9 is just plus or minus 3. Don't forget the plus or minus on that one. and then minusing 2. So I'm going to get negative 2 plus or minus 3. And a lot of people don't like having this on the right-hand side. They switch it around like this. So for the first solution, it's negative 2 plus 3. For the second solution, it's negative 2 minus 3. Here are my two real roots. All right, finally, these last three, actually, I'm sorry, there's those and those, so it's not finally. But here on these next three, it's completing the square. So we're specifically being told to use a specific method on this one. And then on the last three, we're being asked to do the quadratic formula.